Hey guys, let's review linear equations and linear graphs. Remember, all linear functions has a slope, a constant rate of change. Here is our formula. Typically, we like to put our linear equations in slope-intercept form. It's very easy to graph that way, where the y is isolated. If we do not know the y-intercept, we must use the form point-slope, and then we can convert it to slope-intercept form. For standard form, remember that your a and your b, the coefficients of x and y, must be integers. They cannot be a fraction or a decimal. And also, some folks prefer to have the leading coefficient, a, to be a positive. Here we have 2 points, and we're asked to write this as a linear equation. I don't know my y-intercept because the y-intercept is an ordered pair 0, some number. I don't have that. But what I can do is go ahead and find the slope. So let's find the slope of this equation. We have 2 minus -4 over 6 minus -3. This is going to give me 6 over 9, which simplifies to 2 over 3. So my slope is 2 over 3, up 2 and right 3. Now, I'm going to use point-slope form to find my equation, and then I will convert it to slope-intercept form. I'm always going to use my first point given to be the point for my equation for y1 and x1. So we're going to substitute m with 2/3. We're going to replace y1 with -4, and we're going to replace x1 with -3. We're going to be real careful because we have subtracts and negatives in this equation. So I have y minus -4 equals the slope 2 over 3 times x minus -3. Now, I always want you to clean up, so to speak, the equation when we have minus a negative and make it y plus. And then over here we have 2/3 times x plus 3. So if I asked you to identify this equation in point slope, this is what you would give me. Now let's put it in slope-intercept form so we can graph it. I'm going to distribute my 2/3. The 3's cancel here, leaving me with a 2. I'm going to subtract 4 from both sides, and I have y equals 2 over 3 times x minus 2. So my slope-intercept, or I should say my y-intercept, is 0, -2. So let's graph this. We're going to start at 0, -2, your starting point. And then I'm going to use slope to find another point. The slope says to go up 2 and right 3. So we're going to go up 1, 2 and right 1, 2, 3. I could do it again. 1, 2 and right 1, 2, 3. They're going to fall right in line. If I wanted to reverse this and see what the graph looks like on the left side of the y-axis, instead of going up and right, I could go down and left. So I can go down 1, 2 and left 1, 2, 3. Again, it's going to fall right in line with these other points to make a nice straight line. Now, if we were asked to put this in standard form where a and b, the coefficients of x and y, are on the left, I'm going to just take this equation, y equals 2 over 3 times x minus 2. So we need to first get the x term on the left. So we're going to subtract 2/3 x from both sides. I'm going to have -2 over 3x plus y equals -2. Now we can't leave this 2 over 3 as a fraction. It must be an integer. So I'm going to multiply through by the least common multiple of 3. So I'm going to write my equation up here. So when I multiply by 3, I get -2x plus 3y equals -6. Or if we don't want the leading coefficient to be negative, we can negate all of our terms by multiplying by -1. This is another equivalent equation. So here is standard form, here is slope-intercept form, and here is point-slope form. And here's our graph. Many ways to represent this function. Okay, this time is, again, we're asked to write as an equation And look, we have the y-intercept. We have the b value. So now we just have to find the slope. So I have 6 minus 3 over negative 2 minus 0. That gives us 3 over negative 2. I put this together and I have y equals negative 3 over 2 times x plus 3. Let's graph this. I'm going to start at 0, 3. I'm going to go down 3 because of the negative. 1, 2, 3, and to the right, 2. So we can see how our line is sloping downward. It's going downhill because we read from left to right, and this has a negative slope. Now, let's put this in standard form. I'm going to add 3 halves x to both sides. That gives me 3 over 2x plus 1y equals 3. Again, I can't leave this a as a fraction, so I'm going to multiply by 2. The 2's cancel. I have 3x plus 2y equals 6. If I were to ask to put in point slope, which there's really no reason at this point, I would use my first point and I would say y minus 3 equals my slope of negative 3 over 2, and then x minus 0. Of course, I probably wouldn't write the minus 0, but this would be point slope. Let's do one more. I don't have the y-intercept. I do have the x-intercept, but not the y-intercept, and the b is your y-intercept. Yes, we did graph that one, making sure. Okay, so let's find the slope, and I have negative 8 minus 0 over 6 minus negative 6. This gives us negative 8 over 12, and this gives us, they have a factor of 4, negative 2 over 3. I'm going to use my first point for the y1 and x1, and I have y minus 0 equals negative 2 over 3 for my slope times x minus negative 6. Well, since this is 0, I'm just going to say y equals. I have negative 2 over 3, x plus 6. Now we just need to distribute the negative 2/3. So this would be point slope. And now slope-intercept, I'll have negative 2 over 3x. And then a negative times a positive is a negative. 3 divides into the 6, 2, and 2 times 2 is 4. So this is point slope. I'm going to start at 0, negative 4. That's the y-intercept. I'm going to go down 2 because my slope is negative. So down 1, 2, and to the right, 1, 2, 3. If I were to be asked what is the x-intercept, it is negative 6, 0. That was given to us. If we were asked what is the y-intercept, we would say 0, negative 4. Okay, we want to identify the intercepts, the x and y intercept. So my x-intercept is when y is 0. So let's plug in 0. So we have 4 times x, 6 times 0 is 0, equals 12. Divide by 4, and my x is 3. So 3, 0 is 1 point on this graph. And remember, it only takes 2 points. And the y-intercept, I'm going to plug in 0 for x. When I plug in 0 for x, this whole term goes away. So I have 6y equals 12. Simply divide each side by 6, and y is 2. 0, 2. And then I could find a third point by identifying the slope here. So we're working from left to right. I go down 1, 2, and to the right, 1, 2, 3. I could find another point, down 1, 2, to the right, 1, 2, 3. Or I could do the reverse. I could go up 1, 2, and left 1, 2, 3. So there's all kind of points on our linear functions. And there you go. Let's go ahead and put this in slope-intercept. That will be a good review. If I want this in slope-intercept, I'm trying to get the y isolated. So we're going to subtract 4x. I get 6y equals negative 4x plus 12. Divide by 6 and simplify. Y equals negative 4 over 6 has a factor of 2 in common. And there we go. Okay, let's convert this to standard, it says, and then we'll come back and graph it. Well, let's go ahead and graph it now. It's in slope-intercept form. We love this. We're going to start at 0, negative 6. Our slope is up 1, 2, and to the right, 1, 2, 3. Up 1, 2, and to the right, 1, 2, 3. We can back it up and go down 1, 2, and left 1, 2, 3. Now let's convert it to standard. We're going to subtract 2 over the 3x. 2 over 3x, that gives me negative 2 over 3x plus y equals negative 6. We can't have a fraction as our a, so we'll multiply by 3. That gives me negative 2x plus 3y equals negative 18. Or if we want the leading coefficient to be positive, we could say positive 2x minus 3y equals positive 18. Okay, so for this graph, also remember that if I were to ask you what is the interval of increase, so the interval of increase is going to be from negative infinity to positive infinity. All of my x values going from left to right cause this graph to increase. If I said what is the interval of decrease, you're going to use the null symbol. This graph never decreases. There's no x value that causes this graph to go down. Okay, we're going to put this in slope-intercept form and identify some key features. So y equals, we need the slope first. So I'm going to locate two nice points here and here. So I'm going up 1 and right 1. So 1 over 1 is 1, so 1x. It passes through negative 4 on the y-axis, so it's minus 4. My interval of increase is all real numbers. Interval of decrease, we don't have any. No, it never goes down. As x approaches negative infinity, f of x approaches negative infinity. As I go left, the graph goes down in behavior about the end of the graph. Then, as x approaches positive infinity, f of x approaches positive infinity. As I go toward positive infinity, the end of my graph also goes toward positive infinity. We're going to write this in slope-intercept form. Y equals, I'm going down 1, right 1, down 1, right 1. So that's negative x. It goes through the minus 2. My interval of increase, there is none. Interval of decrease, all real numbers. Okay, let's do this last problem, and we're going to write an equation. Heather is raising money to help a family for Christmas, which is 12 weeks away. She begins with $2,000 donation from her friend. Then she collects $175 each week. We're going to write an equation to represent the total amount she has for that family. So Y, which is my total amount collected, is $175 per week plus the initial $2,000. So our domain is going to be the X values, and the X values is weeks. So how many weeks can she collect? Okay, so she's going to start at 0 weeks, and then she has at most is 12 weeks. Then the range is the total money that she collects. What is the least amount of money in 0 weeks? She has that $2,000 donation. Now, we don't know how much is the most until we calculate it. So Y is going to be 175 times the 12 weeks. So again, X is weeks plus the 2,000. So we're going to say 175. Let's get our calculator out. 175 times the 12 weeks she has before Christmas is 2,100 plus the 2,000 upfront donation. So the total amount that she's going to collect for the family is 4,100. And so here is our range. The x-intercept, if we were asked to define the intercepts, so if we were to graph this, this is going to be weeks, and this is going to be the money. So the x-intercept is going to be where we really don't have any, because at 0, we don't start it with no money. At 0 weeks, we have, let's say, $2,000. Okay, so there's not going to be an x-intercept for this situation. The y-intercept is going to be the original amount that she starts with. And then it's just going to increase, and then at week 12, when she gets to week 12, it's going to be cut off. So this from here to here is the domain from 0 weeks to 12 weeks. And then the range is going to be from here at 2,000 up to 4,100. So this part is your range, and this part is your domain.